Right, question 3 here. This data represents thermal expansion. Right, so we have 1, 2, 3, 4, 5 temperatures, and then we have percentage expansions, right? And we want to fit a least squares quadratic of the form y equals a sub 0 a1 times x plus a2 times x squared for the data above, using the statistical functions on your calculator. So here's our calculator. And the first job is we're going to reset. So I'm going to shift, reset, and I'm going to initialize all, pressing 3 there, AC for, I know I cancelled it, so I'm going to go again, shift, reset, 3 for initialize all, equals to, agree with that, and press the AC key then, initialize all. Now to enter in, this is bivariate data with an X and a Y value for each of the 5 recordings. So we're going to go we press the menu button, you see that? Press the menu button there. Then scroll over to that bar charty thing, statistics, and press equals. And now we have this menu here, and we're going to go with number 3. Do you see that? Because we have an A and a BX and a CX squared, which suits us for our to get our least squares quadratic. So we'll type in 3 there, and now we're just going to enter the data. So it's 20 for the first x value, 22.5, 25, 27.5, 30. And then I'm going to toggle up using my keypad there, and I'm going to enter in the y values, 0.31, 0.72, 1.19, 1.88, 3.22. So now I have the data entered in. Now I need to go and get this equation, or the values. In the calculator is A, B, and C, and on the question there is A sub 0, A sub 1. It doesn't matter. We're looking for A, B, and C, right? So we go option, press the option key, and let's try one of these. Regression number 4, I think it is, and there it is, right? So y equals ax plus bx plus cx squared. A is, let's see if I can zoom in on that there. Right, so I'm just going to take a note of that. I'm going to turn off this here, right? A equals 9.044, B equals that, and C equals that figure there. So let's say we go to 4 decimal places. So that's part 1 done there. That's our least squares quadratic of the form sought for there, right? We did it using the statistical functions on the calculator. In part 2 now we're asked to calculate the coefficient of determination, r squared, for the quadratic equation fitted, and comment on the goodness of fit. Well, the r squared formula looks something like this, right? R squared equals the explained variation divided by the total variation. And the maths way of doing that, then on top we have the summation of y hat minus y bar for each of the 5 values, square that, the sum of the squares, right? And down below we have a similar type of a structure, y minus y bar, and that's squared as well. So y bar is the average y value, so we need that. We can get that from the calculator without doing much more. So we just press, I'll zoom out there now, we press our option key. A second now. We press our option key there again, right? Option, press it again, and we see number 2 there, 2 variable calc, and we get some summary variables there for x bar. The average x value is 25, for example. Scroll down there and you can see y bar equals 1.464. So we'll write that in there in our solution. Y bar equals 1.464. Now, after that it gets kind of, it's a bit repetitive, but we'll just do something like this. I'll expand this page here now for the time being. Alright, now. So we're going to need an X column here. So we put in our X values. 20 degrees, 22.5, 25.0, 27.5, and 30. And our Y values, 0.31, 0.72, 1.19, 1.88, and 3.22. And then we can stick in, I'll put in the Y bar value here, 1.464 each time, right? That's just the average Y value. And I'm putting it in there so that it's handy for subtraction. So this column, the next column now is going to be Y minus Y bar. So I'll take away 1.464 from each of these guys down along, right? So 0.31 minus 1.464 gives me minus 1.154. Now you see I've calculated the 5 values of Y minus Y bar, and now I'm going to square each of these values to populate my next column here. So minus 1.154 squared gives me 0.365, working to 3 decimal places. And squaring the rest of them, I have it done already, you see, so that's going to be minus 0.744 squared. Gives us, oh no, I'm looking at the wrong one, I'm after making a mistake there, I'm going back up here. Minus 1.154 squared is 1.332, and so on down along. So now I have my 5 Y minus Y bar squared. That should say squared there, because I've squared each of these values. And now I'm going to add them, and that's going to give me the sum. This is sigma, this means the sum of the Y minus Y bar squared values. And I'll add those 5 there, and that gives me 5.217. Next up then is a similar procedure. I'll make more space, so I go down here, and I'm going to have Y hat. Right now, Y hat, I'll put in the Y values again here. 0.31, 0.72, 1.19, 1.88, and 3.22. Now Y hat, we go back to the calculator to figure out Y hat for each of these values. So here's my calculator. I'm going to press option now, and what am I going to do? I'm going to go for data perhaps. No, back again, press option. 3 for 2. No, back again. The data is still in the calculator. Press option. What do I get? Maybe select type. 1 variable. 3 there. No. I'm going to pause now for a minute. Right, then now we're going to get our Y hat values using the calculator, and we get each of them using the corresponding X value. So I've copied down, you can see I've copied the X and Y down to here. Now I'm going to use the calculator. If I can get up the calculator there, right? So I press option and scroll down, and then you see that 4. So I was here, pressed option, and then I scroll down and press 4 for regression, and number 6 there for Y hat. And to get the Y hat is a predicted value. So for the first X value we've 20 for the temperature, and the press equals now to get the predicted y value. So that's 0.365, right? So I go y hat here, and I get 0.365 to 3 decimal places. And for the next one, then I go back up, just back up and edit to 20, and stick in 22.5 and press equals, and we get 0.617. 0.617 and so on. So I populated my y hat column using the same technique as I showed you there, and now I'm just going to stick in a column of y bar values. Y bar is still 1.464, so I'll just have that down along, and this is just a lot of repetition, this question, no big deal, you know, once you know your calculator. So then I'm going to have y hat, because we're going back looking at the formula, we're going to need y hat minus y bar for each of these. So that'll be 0.365 minus 1.464, and we get something like this, minus 1.09, working to 3 places of decimals, something like that, right? And the next guy then be minus 0.847, and get 0.205 and 0.549 and 1.693, 693, right? And then we'll have to square each of these guys, so we're going to have y hat minus y bar squared in all 5 cases, and that'll give us 1.208. Here will be 0.717. Don't worry if you've 1 or 2 decimal places off according to me, because I'm working from a previous solution where I went to 4 places instead of 3, so it might cause tiny differences. 0.042, and we have 0. That's supposed to be a 3. 0.302, and finally 1.693 squared is 2.867, and then we're going to sum them, and that's going to give us the structure here, the summation of y hat minus y bar squareds, the 5 of them, right, added together, and I get 5.13 5 approximately. So r squared, remember from before, is the summation on top of y hat minus y bar squared over summation y minus y bar squared. This is a predicted variation, is it? And this is the total variation. And we got the figures for these. We have the y hat one there is 5.135 on top, and below we have 5.217, and we're going to turn that into a decimal. So if 5.135 divided by 5.217 equals 0.9842, so we get 0.984 to 3 decimal places. So finally we're asked to comment on the goodness of fit. So r squared equals 0.98 indicates a near perfect fit, right? That's your answer there, because r squared equals 1 would be a perfect fit, right? So that's it for that part of question 3.